in a few minutes. Give everybody a minute or two to trickle in, then we'll get started. All right, looks like attendance is starting to level off. So hello and welcome to the Electric School Bus Familiarization webinar series. My name is Ryan Frasier. I am from the Joint Office of Energy and Transportation. And if you're here for Module 1 overview for bus operators, you're in the right place. And we're glad everybody could join today. Next slide. So just some housekeeping tips at the top. You can submit questions using the Q&A window. So just move your cursor down your screen to find that and submit anything you've got today. Next slide. And we are recording today, so any speaking or use of video is presumed as consent to recording and use of your voice or image. Next slide. This webinar is being presented by the Joint Office of Energy and Transportation. The Joint Office mission is to accelerate an electrified transportation system that is affordable, convenient, equitable, reliable, and safe. And our vision is a future where everyone can ride and drive electric. Next slide. And the Joint Office does support a number of programs that were established by the bipartisan infrastructure law that you can see here. And this includes the Clean School Bus program, which is administered by the EPA and will distribute $5 billion in support of electric school bus deployments. Next slide. So to support the EPA's Clean School Bus program, the Joint Office has partnered with the EPA and the Department of Energy to provide free technical assistance to school districts that are currently receiving EPA funds or are planning to apply for future rounds of funds. So the goal here is really to provide school districts with the knowledge, tools, and information needed to successfully plan for and deploy clean school buses. Eligible entities can request assistance by filling out our online contact form. If you scan this QR code here, it will take you to the contact form, or you can go to driveelectric.gov/contact. You can also email us at cleanschoolbusta@nrel.gov to get access to our technical assistance. Next slide. So here are some examples of items we can help with, but feel free to ask about anything large or small. We have a group of fleet managers, utility professionals, industry experts, and outside organizations that can help with any of your needs. Again, this service is free. There are no strings attached. Please reach out if you need anything. Next slide. So for today, first I'm going to just give a quick intro to our webinar series that we're kicking off today, and then we're gonna get into our presentations. Joining us today, we have Albert Burleigh from Bluebird Corporation, who is going to go over what is an electric bus and why. And then next, we'll have Brandon Reid from Lion Electric to discuss standard operations, controls, and driving. And to close out, we'll have Mark Richardson from Thomas Bus and Daimler Truck going over charging procedures and infrastructure. We are going to hold Q&A until the end, but feel free to put questions in the Q&A box as we move along. If you have something for a particular presenter, you can put their name in along with your question. That would be great, so we can streamline it at the end. Next slide. So, as hopefully everybody knows, this is the first in a 4-part series on electric school bus familiarization training. The Joint Office and NREL have partnered with the International Transportation Learning Center and school bus manufacturers to provide these courses on the fundamentals of electric school bus technology. We will be recording each of these sessions, as I said, and we are also going to be releasing testing materials so that school districts can incorporate these into their internal training programs. So please look out for those in the future, and please share those with your peers as well so they can incorporate them. Next slide. Obviously, this is module 1, geared towards drivers and operators. We will have registration for modules 2 through 4 coming soon, and those will be aimed at technicians, but really all of these are going to be relevant to anybody in your organizations that is interested in the fundamentals of electric school buses. Next slide. So today's moderator is Maurice Beard. Maurice has had a transportation career spanning over 3 decades, starting as a coach operator at Valley Transportation Authority in San Jose, California. Maurice moved into positions as line instructor, transportation supervisor, and then full-time technical trainer, overseeing new operator classes. For his last decade at VTA, Maurice served as technical training supervisor, where he and his team kept VTA's operators updated with the latest industry knowledge and training techniques. I'll kick it over to you, Maurice.
Thank you, Ryan. I appreciate it. And we at the International Transportation Learning Center appreciate being able to partner with you on this very important webinar series. So as Ryan said, on the first module, we're going to deal with what is an electric bus and how that works. We're going to speak with Albert Burleigh from Bluebird. Albert.
Thank you, Maurice. And thank you for allowing us to be a part of this series. Looking forward to it. We'll go ahead and get started. If you want to go to my first slide, I'll give you a quick agenda of what I'll be speaking on today. So first, it'll be defining an electric school bus. We'll list the benefits associated with electric school buses. We'll explain some general safety and emergency preparedness, including en-route emergency protocol for electric buses, and reference the steps for shutting down the high voltage system. And we'll also describe the process of regenerative braking. Next slide. So to help describe an electric bus, let's review the various types of vehicles in terms of how they are powered and the level of emissions for each. So first, the one that I think most folks are familiar with is the internal combustion engine. You see that graph there. The first on the left is internal combustion engine, or ICE. That's a vehicle that runs on fuel, such as gas, diesel, or propane. And then you have hybrid electric vehicles. Those are powered by internal combustion engines in combination with one or more electric motors that use energy stored in batteries. A hybrid does not need to be charged, as it switches seamlessly between electric power or gas power. And when it's running on gas, it recharges through what's called regenerative braking. And we'll discuss regenerative braking a little later. There's also something called a plug-in hybrid, which, like hybrid electric vehicles, a plug-in hybrid has an internal combustion engine and an electric motor. Compared to a traditional hybrid car, a plug-in hybrid has a larger battery and offers a greater all-electric range. And it can charge from regenerative braking, but they also need to be plugged in to charge fully, to fully charge their electric battery. And you can see as I'm stepping down, the emissions on each get a little bit better because you have vehicles that are operating more in electric power than they are in combustion power. And then last but not least, you have battery electric vehicles, which we're talking about today. They're powered only by batteries and are charged by an external power source, which would be an electric charger, so an EV charger. So that kind of gives you an idea of what is an electric vehicle and how it compares to other vehicles. Obviously, electric vehicles have zero emissions, which you can see from this chart here. Next slide. So let's talk a little bit about the benefits. Really, why is there so much growth in the school bus market with electric school buses? And it is the fastest growing segment in the industry at the moment. But that's because there's many benefits. First and foremost, there's zero emissions. There's reduced maintenance costs. The very quiet operation as compared to a diesel bus, for example. Availability of grant funds. We'll talk a little bit about that. They have an outstanding performance when you compare them to diesel buses, and also something called vehicle-to-grid technology, which I'll explain further. So let's review each of these benefits separately. Next slide. First, zero emissions. Really, the primary benefit of electric school buses are that they have zero emissions, which provide health benefits for the students that ride on them, and also for the communities where they operate. They also have a very positive impact to the environment, which is why many states are setting goals or legislation to transition to electric vehicles. So on this slide, you can see there's several states which are listed on the right side of this slide have emissions reductions or legislations, emission reduction legislation or goals. And 6 of those states, which are depicted on the map, have enacted binding legislation for school bus fleet transition to go to zero emissions or electric school buses. And many more states are increasingly including either funding opportunities to transition to zero emissions or some kind of mechanism to help offset the upfront cost of these school buses. And if you look at all those states that have some kind of adopted some kind of transition legislation or goals, it actually impacts 34% of all the school bus fleet in the U.S. So of just the states that are looking at this, it's a considerable number of buses that will eventually get transitioned to electric power. Next slide. Another big one, another big benefit is grant funds. There's funding for the bipartisan infrastructure law. The EPA's Clean School Bus Program provides actually $5 billion over 5 years. So that's 2022 to 2026 to replace existing school buses with zero emission and low emission models. Under the program's multiple grant and rebate funding opportunities to date, the EPA has already awarded $1.84 billion to fund over 5,000 school bus replacements at over 600 schools, of which 96% of those replacements are electric powered school buses. The EPA school bus funding can also be used to purchase charging infrastructure in addition to the EV school buses, which is a huge benefit. And districts can stay ahead of their state emission regulations for a fraction of the cost using these abundant funding opportunities for electric zero emission school buses and make ready programs for charging infrastructure. So really a huge benefit for electric school buses. Next slide. Another benefit we mentioned earlier is reduced maintenance cost. So the number of moving parts in an EV drivetrain is measured really in dozens, while it's measured in thousands in an internal combustion engine counterpart like a diesel bus. So there can be up to 100 times fewer moving parts in an EV than a diesel, which you can see why that adds up in big savings. So in addition to that, electric school buses have what they call regenerative braking, which serves really a dual purpose. First, it allows the motor to act like a generator to put energy back into the battery, but also slows down the bus while using less of the service brakes, which actually reduces brake wear and improves cost on these vehicles. So overall, maintenance is greatly reduced, with reported costs from customers going down between 60 and 80% versus a combustion engine drivetrain. And there's also no oil to change, no timing belts to replace, spark plugs and ignition components or emission controls are all minimized, as well as fewer bearings and seals, just to name a few. So you can see real electric buses have a big advantage in terms of maintenance over their diesel counterparts. Next slide. So another benefit is the quiet operation. So besides being environmental friendly, electric buses are quiet and help reduce noise pollution. And this reason is simple. They don't use combustion engines. Diesel school buses emit more decibels at miles per hour when compared to electric vehicles. So the quiet nature of an electric bus increases driver awareness and allows passengers to have a relaxing and enjoyable ride, which is especially advantageous for passengers with special needs. And further, it helps reduce noise levels in areas surrounding the bus route, contributing to quieter, more peaceful communities. So electric buses are actually so quiet that they have to have a noise generator installed that actually emits a sound at low speeds to alert students and other pedestrians that the bus is approaching. Next slide. So performance. Electric school buses are superior to their diesel counterparts in terms of performance. For one, they have exceptional power for acceleration, outperforming diesel buses. They accelerate quickly, which is not something that typically we train drivers to do because it will consume more energy. But that quick acceleration does provide a benefit if, for example, you have to get up on a highway quickly or scale a hill, for example. So really that extra performance is a nice benefit on electric vehicles. And also the batteries are typically installed between the front and rear axle and between the frame rails, provides kind of a lower weight, a better weight distribution because you have a lower center of gravity. This provides really superior handling on these buses, again, as compared to their diesel counterparts. Next slide. Vehicle to grid. Another benefit of electric buses is the capability for vehicle to grid or V2G. And although this is not yet widely used by school districts, it provides the opportunity for the local utility company to buy back stored energy in the batteries when the buses are not being used, like at nighttime, over the weekend, or during the summer when there is the highest demand on the grid. And V2G also creates the ability to redirect that stored energy to power other structures like a building or a fuel island. This can be a big benefit in the event of a natural disaster. So another nice benefit. So that kind of reviews the benefits. Let's move on to the next slide and give you a little bit more information about regenerative braking. We mentioned that a couple times. So what is it? Regenerative braking is a way of taking the kinetic energy from an electric vehicle's momentum and converting this into electricity when you need to slow down. So when the throttle is released, the electric motor will act as a generator to slow the bus down while at the same time feeding energy back into the batteries. This really provides two benefits. First, it extends the driving range of the vehicle and it reduces brake wear as you will use the service brakes much less often than you will on a typical school bus. Another important item to note about regenerative braking is that the battery state of charge, or SOC, must be below 80 to 90% for the regenerative braking to take effect. And next slide will just provide a scenario for that. So, for example, because this is something we hear a little bit in this in the electric school bus world, a school bus driver complains that the regenerative braking is not working at the beginning of their route when the bus is fully charged. So when the battery is fully charged, there's actually no more space for that power to be stored into the batteries through regenerative braking. So it won't work unless the batteries actually have a lesser charge somewhere between 80 and 90%. Something important for drivers to know because it is a common issue that we hear, but it is important that those batteries don't regenerate or that motor doesn't regenerate when the battery is already completely full. So that's just how the system is designed. Next slide. So another very important topic for a school bus operator is understanding some general safety guidelines. Like any school bus, regardless of how it's powered, it's very much the same way, and it's important that a driver do a thorough pre and post trip inspection, that they really have very vigilant driving standards like they would for any product, and they complete proper driving training. So that's true of any school bus and also true of an electric bus. But what's unique about an electric bus is drivers have to have high voltage system awareness. We'll talk a little bit about that in a moment. Must know how to both enable and disable the high voltage in the event of emergency, and be aware of the quiet operation and why that's important to understand as a driver, because obviously in many cases you can't even tell the bus is running because it's actually that quiet. So something as a driver or operator you have to be very aware of, as you don't have that same kind of sensation, that noise, as you do for say with a diesel bus. Next slide. So I mentioned high voltage on the previous slide. And so just so you understand it, for automotive applications, any voltage greater than 30 volts AC or 60 volts DC is considered high or hazardous voltage due to the potential to produce serious injury or death through electric shock. So electric buses do have high voltage systems. They actually range anywhere from 400 to 800 volts. So understanding proper safety guidelines is really key with these products. Next slide. So really the most important aspect of safely operating electric school buses is understanding how to properly disable that high voltage in the event of an emergency. So the procedure is actually very simple and straightforward. First, you remove the key from the ignition. And second, you look for the disconnect switch in the 12-volt battery compartment and you turn it off. Because without low voltage like 12-volt power, the bus cannot have high voltage, cannot engage without the 12-volt being on. So really a very simple procedure for shutting down the high voltage whenever it's necessary to do so. Next slide. Here's a diagram of electric bus showing locations of some of the high voltage components. This is something that would be reviewed during a more extensive training, not only for drivers and technicians, but also for first responders. As you can see, the high voltage components are located on the EV chassis, which are below the floor line. Something important to be aware of, especially if you're a first responder, in the event they must cut into the bus to extract occupants. So that's something we train to, all EV OEMs train to that, to make sure that first responders and everyone's aware where those high voltage components are located. Next slide. So what should you do in the event that an electric bus is in an accident and either submerged in water or if a fire occurs? First and foremost, first thing you do is call emergency responders. But if it is submerged in water, be aware that the high voltage system is isolated from the chassis and designed not to shock or energize surrounding water. You should still shut down the high voltage, like we mentioned before, if that's possible. There's no issue with doing that. So that is something you would try to do if you're able to do in the event of an accident. Now, if it's involved in a fire, you should not attempt to extinguish it. It's important to evacuate the vehicle and stand upwind of the fumes at a very safe distance. And next slide. Lastly, understanding how to tow an electric vehicle in the event of an accident is also very important. The preferred way to tow it is to lift it from the rear and tow from the rear. In that case, it's just like any other vehicle, nothing you need to do differently. But if you're towing it from the front, if that's necessary, it is required that you remove the drive shaft. This is required because if it's not removed, the motor will turn and create energy, which will cause damage to the motor. So we always train to remove that drive shaft if you're picking it up from the front, and those rear wheels will be turning. So something important to note. That concludes my section, and I will now pass it back over to Maurice. Thank you.
Maurice, you're muted.
Sorry about that, folks. Again, we're gonna just move right along here with Brandon Reid from Lion Electric, talking about standard operations, controls, and driving. Go ahead, Brandon.
Maurice. Hello, everyone. I'm Brandon Reid. I'm the Director of Customer Success at Lion Electric. And as he mentioned just now, I'm going to be reviewing standard operations, controls, and driving for electric school buses. So next slide, what we're going to just review real quick is the learning outcomes. So but these are the three basic topics that I'm going to be covering. And by the end of our chat, everybody, I hope that what you're going to be able to learn is just be able to describe the functions and controls of an electric school bus, identify procedures for effective operation, identify key similarities and differences to traditional ICE or internal combustion engine bus. So that's what we're going to get into. We'll start on the next slide. And on that one, I'm just going to kind of go over at a high level a comparison between internal combustion engine buses and electric school buses. So what we see here, the main difference is, of course, going to be the propulsion, right? So the high voltage electric powertrain components. So what we have is going to be motor and inverter that supplies the propulsion to those wheels, electric pumps and things like that to move fluid and for steering, hydraulic braking, and a compressor that is supplying any air to the pneumatic brake suspension and whatnot. So obviously we're not going to be running these off of a pulley system as we would on a normal vehicle or a PTO, but instead these are all going to be ran by the high voltage system. One thing to note there at the bottom though, everyone, steering, suspension, interior controls, and brake components are using a standard low voltage 12 or 24 volt system. And some manufacturers also offer a high volt power heating and AC system. So there's some familiar items there, as well as some options on how to do heat and AC. And we can go ahead and move to the next one, please. Okay, so we've got a little graphic that you can go ahead and start. So the first one is going to be just number one, propulsion. So what we see there, the battery is sending power to those rear wheels by the way of the motor or generator. Also interacting in that is going to be the 12 volt battery system to start that. As that drains down, we see that okay, maybe now we're coming to a stop, we're coasting, we're off the accelerator. As Albert from Bluebird mentioned, this is regenerative braking right here. So we're slowing down, we're coming down a big hill, we're actually putting battery power back into the battery. So you see that propulsion battery going up a little bit in its state of charge. And last but not least, certainly not anything we want to miss, is charging. So it goes through some sort of converter, whether that be at the charger or on the vehicle. And of course, you know, mid-route or overnight in a driver's case, we would be refilling the propulsion battery and getting that state of charge up to hopefully 100%. So that's just a quick review of all the cycles that an EV vehicle can work under. Go ahead and move to the next slide there. So, you know, one thing that we hear from drivers a decent amount is, you know, hey, is this going to be some sort of rocket ship that I'm climbing into? That's not going to be the case. So what I've done here, we've added slides that are added pictures that have got a 2020 electric vehicle and internal combustion vehicle in it. As you see, they're not really that different. You know, we still see our standard seating arrangement with analog gauges, standard cluster indicators, HVAC, radio controls, lights, switches, mirrors, seats, all that. So again, not very different than what we are used to. It's still just a normal modern bus at the end of the day. It's just a little bit different on the combustion as we are, or the lack of combustion as we talked about. Moving on. All right, so one thing I want to focus on a little bit is the instrument cluster. So we do have, of course, all the normal stuff that you would see in a normal vehicle. We've got, of course, our speed, you know, our coolant temperature for you know, no matter what system it is, whether that be an internal combustion, we're talking about our radiator, and a EV, we're talking about for the batteries. You know, we've got a 12 volt gauge, but then on the right, what I want everybody to take a look at is just a little bit of the differences that we're going to see specifically on the gauge. So whenever we're looking at this, instead of a fuel level gauge, we're now going to see what we call a state of charge gauge. And that's going to show you as a percentage of 100, you know, kind of like your gas gauge, just how much battery power or state of charge you've got left. And we'll review this a little bit in the future, but there's a power usage efficiency gauge somewhere located on this just to show you how efficient you are being. And that's usually in the place of a tachometer, as well as, you know, a battery temperature gauge or possibly some other high voltage component gauge like a motor versus an oil pressure gauge. And you know, as I mentioned, yeah, instead of having an engine temperature gauge, we're most likely going to be having, you know, some sort of gauge that shows the EV motor temperature. So again, it doesn't look very different, but the information this displays is a little bit different than what we're used to. At the end of the day, you're still going to know how fast you're going, and you're still going to have a really good picture of everything that's going on with your vehicle. Go ahead to the next slide, please. So low voltage power supply, power accessories. So every vehicle that we're talking about today also has some sort of low voltage supply. So these are usually just your normal 12-volt batteries. You need to maintain these just like you would on a normal bus, your 12 or 24-volt system. And this is powering such items as your dashboard, your electrical panel, lights, accessories, emergency buzzers. So again, very similar things that we're all used to, and just know that that's going to have a familiar voltage as well. It's not going to be a high volt item. So, and one thing that we're going to talk about on the next slide, if we want to move on, is going to be our DC to DC converter. And I know that's a little bit techie for some people here, but essentially what that is going to be the alternator of the electric school bus. So one thing we get asked about sometimes is, okay, we've got these two systems, how do they interact with each other? And we're starting the vehicle with the 12-volt system. How does that get topped back off, or how does that voltage get maintained while we're driving? Well, that's going to be the job of the DC-DC converter here. Again, very similar to an alternator. And it's going to feed energy back into the low volt system to make sure that it's always being maintained. It installs between the high and the low volt systems, and it just converts that power back into a usable power for the low volt system. So making sure that you've always got the juice that you need to get started every morning. All right, next slide, please. Functions and controls. We're all very happy to hear that we've got our everyday HVAC, right? So the options are going to be just the same thing that we've got in internal combustion or traditional buses. So we've got within electrical heating, we've got several ways that we can do that, whether it be heat pumps, thermal heating elements, or electric fluid heaters and fans. We do have options for electrical heat to maintain you on those cold mornings. Ventilation, of course, we've just got fans and blowers that move the air into and throughout the cab. And same vents as a traditional bus for this. And on the far right, everybody's favorite, air conditioning. Once again, does utilize heat pumps at times, or a high voltage AC compressor from the high volt system. So both use just a regular compressed refrigerant, just like a normal AC system would on a car or bus that we're used to. Oh, no, you're good. So Albert also mentioned briefly the pre and post trip inspections. So I'll expand on that just real quickly. Kind of the big takeaway here is that there's really no more work that you're going to need to be doing as a driver. So you're going to appreciate that. There's going to be actually a little bit less because, of course, we don't have an engine. We don't have a transmission. There's just a few very long dipsticks that we're not going to have to pull out and check in. So you can use your old standard forms. We put a few examples right here. And similar systems mean, the pre-trip is essentially going to be the same. So you can see there, the one in the front, maybe what we're seeing is some people are utilizing someplace to put the beginning state of charge, the beginning temperature, the beginning odometer reading, just a little bit more ways that if you're tracking your fleet with a full EV fleet, or even a partial, that you might be able to have a little bit more data on state of charge. So next slide, please. So effective operation, this is a big subject that I want to introduce because this may be something that not everybody has really heard of. It's called battery preconditioning. So what is it? I'll read from the slide here. It's a function of all electric school buses that engages the high volt systems to preheat or cool your electric vehicle's battery and cabin before you start driving. So how does that work? Typically, there's some sort of system set up within each bus that it allows the driver or operator to schedule this to come on. So hopefully by the time you get there in the morning in your afternoon route, what have you, you've got a nice warm battery, cool battery, depending on the conditions. And overall, this is going to optimize the vehicle, make sure that the bus is ready when needed. And what this is going to do, it's going to rely on the power of the external grid powered source. So typically that's going to be your charger. So whenever the vehicle is plugged into that charger, it will be able to do this battery preconditioning process. The reason that we want it hooked up to the charger is just so it's not going to be using any of the electricity from the bus that is stored in the batteries, and instead using it from the grid. So you're not going to come in with reduced range. So in hot weather, obviously what we're going to see is the vehicle cooling the batteries off using air conditioning or cool to coolant. In a cold weather system, we're going to have heating that goes to these batteries to make sure that they're up to proper operating systems. So again, the goal here is for the vehicle to be able to hop in and drive quickly, and for it to be comfortable for the driver, because as you see on the right, not only is it going to be performing better and getting maximum range, if you're doing this, you have a few options to heat and cool the cabin as well. Everybody appreciates that, right? So battery preconditioning is something that you'll certainly hear a lot more about, and as a function of all buses that is well appreciated by most. Next slide, please. So startup and shutdown. You know, again, the takeaways here is that this is actually very similar to a traditional vehicle. Typically, we're going to see either a button or a switch like we're used to, and upon ignition engagement, what's going to happen instead of, you know, you turning something and then the mechanical, you know, flywheel starters start turning. Instead, what you're going to do, you're going to send a signal to a module that engages the high voltage propulsion system and essentially starts the vehicle, right? So essentially you're turning on a computer. You will find manufacturer specific indicators or something on the dashboard somewhere that is visible to the driver that will indicate that the vehicle is started. At times, the surrounding area, the environment is loud, and these vehicles are actually so quiet that you cannot tell that they're started otherwise. So as you see below, operation is very quiet or silent. And some manufacturers do have a bit of a different order, but speak with your vehicle trainer on that when you see your brand new bus. And for shutdown, it is important that you ensure all high voltage modules are off before any charging or errors may occur, but otherwise it's a very standard process. Shut the bus off, turn the key off, push the power button, what have you, and you should be able to walk away. So once again, a few different steps here, but not wildly different than what we're used to on a traditional bus. Next slide, please. And shifting. So I want to talk about the electrical motor actually, because for the most part, there are no transmissions in these buses. They're all direct drive. So that means that you do not have your gears 1, 2, 3, 4. All you're going to have, as you see here on the right, is just going to be drive, neutral, and reverse, and in some cases possibly a park gear. But we do not have a transmission that is shifting. So as a driver, you will not be feeling that little bit of kick whenever the vehicle shifts. You will, of course, not have to do any shifting on your own as the vehicle is direct drive. So, you know, whenever you want to go forward, of course, we would just press drive. Whenever we want to go reverse, we would of course, you know, be backing up, but that would be the only thing that we need to do with our transmission there. So shifting is very simple. We can go ahead and move to the next slide. And let's talk about the brakes for a moment. So braking systems on electric school bus, once again, we're talking about things that are very similar to your traditional buses. We've got air brakes or hydraulic brakes. Air brakes have the same components as an ICE bus. You know, we're not using you know, anything EV specific here like we might think of on some of our consumer vehicles. And then many of these electric school buses have a high voltage powered air compressor to feed the pneumatic system, which would probably be the most drastic change. But once again, it's just another air compressor, but instead of operating off of a pulley system or a PTO, it's just operating off of our high voltage system, as you can recall. So hydraulic brakes, very similar. You know, they will run on a hydro boost system, you know, fed by the power system, since there is power steering system. I'm sorry, since there's no vacuum in an electrical bus. Many of these electric school buses also come with a low voltage backup pump to provide emergency braking capabilities. And that's just in case you ever have a high voltage failure, you're always going to have braking power. So again, air brakes and hydraulic brakes are certainly options on most of these buses. And as we see on the right, and Bert has spoken about, regenerative braking plays a large role in slowing the bus down as well. So kind of an added benefit to your EVs right there is that it is reduced braking, as we've heard. So next slide, please. So this is a big one, interpreting power usage. All vehicles are equipped with some sort of control module and a graphical interface that analyzes and displays live power consumption. And the reason that this is really important is because as drivers, you're all going to be wanting to know how much range you have, how much state of charge you have. We're always keeping an eye on our fuel gauge, right? So it's going to be the same thing here. And this is a really big tool that you drivers can use on your daily routes. You know, not only to kind of figure out how much mileage or how much state of charge you've got left, but how efficient you're being on this certain drive, and you can find ways to improve that, hopefully, if it's coming a little bit under expectation. So once again, each one of the manufacturers here differ a little bit in the way that we display this information, whether it be gauge, whether it's something just, numbers on a dashboard, what have you. But the topic, wants to cover just how efficient you are being, and that can also be covered by the trainer of your specific manufacturer. So make sure that what you're taking away, when you're looking at the bus for the first time and looking at these gauges, is just understand the information that's being displayed, and how to use it to be more familiar with the environmental impacts on range. When you see a really cold day or a really warm day, how are things being affected there? And of course, overall, just how to use less energy and become a more efficient driver. It is up to the driver to drive more efficiently, right? So next question, please, or next slide. So battery state of charge. Whenever we come up to a low charge situation, which hopefully does not happen, and but it's bound to at some point. So say you're mid route and you realize, I've got a situation here where I don't know if I'm going to be able to make it back to the yard or to the stop because I've got low state of charge. What we would recommend first is to immediately turn off all non-critical electrical loads. We're trying to just be as efficient as possible. So any impacts that we can remove from that battery load, we would want to do that. And again, be efficient, rigorously use that regen braking, minimal use of the accelerator, drive at the minimum safe speed, and that's going to lower your overall usage. If it comes down to it, unload if it's convenient, and worst comes to worst, stop in a safe area, and you're going to have to just tow the vehicle to a charger. So again, hopefully this does not happen, and hopefully we've all got the tools in our back pocket needed to know when we're going to run into this situation and be able to see it before it happens. But one thing we can do during our general route planning to also assist with this and avoid any low state of charge situations. Anytime that you're looking at a bus, make sure that you're calculating the total range, making sure that it makes sense for whatever route that you are putting it on. We're also needing to, as we mentioned, take into account the environment, the temperature, and the weather. All these things can have an impact on efficiency and overall range. Take into account the efficiency of the driver. If somebody's got a bit of a lead foot, of course, their efficiency is going to be a little bit lower until those habits change. And is there any mid-route charging available? If we need just a little bit of time to top off, just to get back to the yard, what have you, to get away from the field trip, make sure that that's available on your general route planning as well. So next slide, please. So effective operation. So guys, this is really the last part for me here, but I really think it's important to end with this message that as an effective operator of these new buses, these new style buses, you'll need to get into some new efficient habits. As you already know, these EVs shine in conditions where stopping and starting are common, such as bus routes, right? So where multiple slowdowns, stops, whatnot. That way you can use the regen brake to its absolute max efficiency. By driving one of these buses, everybody, you're already much more efficient than one that uses fuel. So all we can do is just work on increasing our habits to become even more efficient, maximize your driving range. As you see below here, what those would be is minimizing frequent acceleration, eliminating aggressive acceleration and excessive speed. So when I say those two things, I certainly don't mean that minimizing frequent acceleration. We're obviously on bus routes. Some acceleration is going to happen no matter what, but what I would say is anytime you can minimize that when you're cruising or coasting on the highway, anytime we can stay off the throttle, obviously we are using less of the energy. The third point there is keep high voltage accessory usage to a minimum. Some of our biggest impacts is going to be our high voltage heaters and the high voltage air conditioners or coolers. So anytime that we do not need to run that, of course, that's going to make you more efficient. If you have a selectable regen power, like we might see on some buses, some have 1, 2, 3, some are standard set at 1 all of the time. But anytime you do have the ability to use that number 3, if it's going to be your highest, do that. That's going to be your maximum setting. If not, you're just throwing some efficiency away. Modulate that accelerator pedal a little bit to slow the bus down with the regen brake. What we find is that when you are coming to a stop, You know, releasing that throttle pedal a little bit later possibly is going to allow that regen brake to take over and once again maximize the efficiency right there. Preheat the cabin, as we spoke about, whenever the bus is connected to a charger. Again, as we discussed, that's going to overall make the bus nice and warm if it has that sort of option or ability. And it's going to let the batteries be at the proper operating temperature and not need to take any of the state of charge away to do that as you were driving. You know, crest your hills at a speed that allows you to coast all the way down. So you may, you know, come in 5-10 miles an hour lower. So you can just let off the throttle completely, allow the vehicle to roll down using the regen brake all the way down. And last but not least, talked about it a lot, but on these hillier routes, just take full advantage by maximizing your regen brake. Anytime that you can use that regen brake, anytime that you're not actively on the throttle pedal, will upgrade your efficiency a bit. So drivers, you truly do make the difference. Everybody, that's really about it for me. So thank you all for joining today, and especially to the Transportation Learning Center for putting this together. And I will see you at the Q&A.
Thank you very much, Brandon. Appreciate it. You know, I can't overstate, along with everyone else, the importance of the operators understanding and mastering regen braking. It's very, very important, and it helps you with your efficiency. Lastly, we have Mr. Mark Richardson. He's going to discuss charging procedures and infrastructure. Go ahead, Mark.
Thanks, Maurice. Hello, everyone. I'm Mark Richardson, a charging infrastructure consultant with Thomas Built Buses. Today, I'll be focusing on the vital aspects of charging infrastructure and inspection procedures from the driver's perspective and in the context of charging electric school buses. So with that said, let's get started. Next slide, please. So some of the learning outcomes will be to be able to explain the difference between AC and DC charging, also being able to identify the different types of charging stations and their components. And then lastly, we'll review some recommended trip inspection and operation procedures as it relates to charging and electric school buses. Next slide. So the difference between AC and DC charging, I think an important takeaway here is understanding where the conversion of that power happens. AC charging provides alternating current to buses, while DC charging delivers direct current. Onboard chargers will convert the AC to DC for batteries in AC charging, whereas chargers directly convert AC power to DC in a DC charging setting. AC charging generally offers slower charging speeds compared to DC charging, which provides faster replenishment. To think about it in another way, AC is often used for like an overnight charging application, while DC can be used in both midday and overnight applications. To give a better explanation or a better way to think about level 2 AC charging, it's going to operate typically off of a 240 volt single phase power source, which is similar to what's used for like large appliances or an electric, say, dryer or oven, which will typically require higher voltage for efficient operation. This means that, you know, level 2 chargers would be very popular because you have that single phase power in residential settings where on the DC side of the house, those are typically fed by 480 volt 3-phase power, which you typically would find at like a commercial facility. Next slide, please. So charger components and port locations, obviously, you want to be intimately familiar with your bus, and buses are typically going to come with charge port locations in various areas depending on how it's ordered. Here's a depiction of a bus that can either be delivered with a front charge port or a rear charge port. Obviously, where that charge port is located is going to determine how you park that bus when you get back to the depot in the evening. If you've got a front charge port and you back your bus in, you know, either you're going to realize you need to turn the bus around for the charging cable to reach the port, or someone else is going to have to do it later that evening. So again, just knowing where your charge port is and knowing how to park the bus so you can ensure that the charge cable can reach the port is key to your operations. Next slide. Looking at the different ports and plugs, there on the left-hand side, you've got your AC plug and port. It's a J1772 port and plug. Essentially, that's what delivers your AC power to the bus. And then the onboard charger, like we previously discussed, converts that AC power to DC power in order to charge the batteries. There on the right-hand side, you've got your CCS or combined charging system DC plug. It looks like the J1772 plug on the left, except if you'll notice those two large contactors on the bottom, that is where the direct current is fed into the bus. So when you, let's say you have to, for whatever reason, charge that bus in a public setting, when you pull up to a charger, you'll be able to identify what kind of charger that is based on what that port looks like. If it doesn't have those two large contactors at the bottom and it just looks like a standard J1772 plug, it's going to be typically a level 2 AC charger. But if you do see those large contactors at the bottom, then you'll know this is a DC fast charger. Also there in the middle is just a couple more examples of where charge ports could be located, right? So on the top picture there, they've got the charge port right there on the nose of the bus. And then in the picture depicted on the bottom of the slide here, they've actually got that charge port located on the rear of the bus. Next slide. So now we'll just cover charging procedures, things to be aware of as a driver. And I've laid out sort of like a 5-step simple charging procedure here. Number one, and really, in my opinion, the most important is you want to initially inspect that charge head for cleanliness and damage. You don't know who previously handled that charge port. They could have dropped it. They could have gotten some mud or debris inside the charge head. So with that said, you do not want to go and plug that charge head into the bus, because you will be essentially cramming debris inside of the charge port, which would not be a good thing, right? Also, checking for damage. If they did happen to drop that charge head, it could have cracked. Some piece could be missing. So just ensuring that your charger and charge head is always in good operating condition and is free of debris. Secondly, you'll just open the charge port door and cover. You can see there in the left-hand middle picture, your charge port may look a little different depending on what bus you purchase, but ultimately there'll be some sort of cover over that charge port, whether it's a single door or two covers covering both the AC and DC connectors. Either way, you just got to get that open so you can plug that charge port or charge head in. Once you've plugged the charge head in and it's seated, you'll know because you'll hear a click. These charge heads do have a latch on them that essentially will hold that charger in place once that latch is able to seat and click. Step 4, you're going to look for some sort of blinking indicator light to confirm that there is communication between the charger and the bus. Also, inside the bus, the dashboard indicators will display charging status. I would say one thing you want to be sure to do here is ensure that that charging process actually starts. So when you first plug a charge head into a bus, there's going to be this handshake process where the bus talks to the charger and they make sure that, you know, certain parameters are met, and then the charging process will start. There are scenarios where you plug the bus in to charge, and if you just walk away, that handshake process could fail, and then the bus never starts to charge. So the one thing you do want to ensure is that that bus starts successfully charging before you leave it. And then lastly, once the charge session is complete, you can stop charging in a couple different ways. If it's charged to 100%, then it'll stop the charge session itself. But if not, there's usually a button there on the charge port. You can see in step 5 there, you can see the driver is pushing that stop button to stop the charging session. And then also, you can also stop a charging session at the charger. There's usually some way to stop it. You can see there on the bottom right-hand picture, For this particular charger interface, it has a stop button on the screen that you're able to press. One thing to be aware of is chargers do have an emergency stop button. That should not be the way that you would want to typically stop the charge session. You only want to hit that in case of an emergency. Otherwise, sometimes you have to go through a bit of a reset process to get that charger back online. And that's really just not the proper way to stop a charger. One other key indicator that the charge session has stopped successfully is inside of that charging port, there is a lock motor that will physically press down on that latch and not allow it to release. So once you've successfully stopped the charging session, you can audibly hear that lock motor release. And if you're able to just, press the latch button and the charge head pulls out freely, you know that that charge session was stopped successfully. Next slide. So let's cover some example trip inspection procedures. Obviously, you want to follow whatever trip inspection procedures that your fleet has laid out, but this is just to give you an idea of what some of those could be as it relates to an electric school bus. So this is outside of the bus. You're going to perform the initial walk around of the bus just to ensure that all of the exterior panels are closed. And then you're going to review the state of charge of the bus. This is super critical when you initially inspect the bus before you take it out on route. Ensure that you've got enough charge. The state of charge on that bus is high enough that you can cover the route you're about to run. We have ran into some scenarios where drivers have hopped into electric school buses, did not confirm the state of charge before they left out on route. And, a quarter of the way, halfway through the route, they realized, oh man, I might not have enough state of charge, so I've got to head back to the depot. So again, very critical that you confirm that your state of charge is where it should be in order to complete your route. Once you've done that, you can go ahead and press that stop charge button, either there at the port or on the charger itself. And once that charging session has ended, like we previously discussed, the lock motor will release. You can then press that latch button and disconnect the charge head from the charge port. Next slide. Once you've done that, obviously, this is sort of a step-by-step procedure that you can go back and reference if needed, but you're going to place that power feed connector back into the charger retaining port. And from a best practices perspective as a driver or operator, I'd say this is also key and critical. You don't want to leave those charge heads and cables just laying on the ground. Buses can run over them. They can get dirt and debris inside of them. So always as a best practice, you want to return that charge head back to whatever retaining port it has there at the charger, and also make sure that those cables are free and clear of any bus tires, etc. You're going to go ahead and close your charge port covers and access door. And at this point, you can perform the power off or power down portion of your pre-trip inspection. The front hood can be opened up. You can inspect fluid levels, steering components, and braking systems. And once done, go ahead and close that hood up, all panels, access door, and ensure the bus is buttoned up outside before you head into the cabin. Next slide. So this is once you're inside the cabin, some example pre-trip inspection and operation procedures to be aware of. And again, this is just sort of a step-by-step look. Every bus varies a little bit, but this is just a look at one of the electric school buses that are out there. So step one, you're going to turn the ignition switch to the on position. At that point, you will hear like a series of relays and electric pumps and fans starting, etc. But once that happens, you want to ensure that your parking brake is engaged. If not, go ahead and pull out the yellow parking switch to engage the parking brake if needed. From there, you can turn the ignition switch to the start/crank position and release. The power on process may take up to 1 minute, but once the vehicle high voltage is engaged, you will see some sort of illuminator or indicator to let you know that high voltage has been engaged. And the reason that power on process can take up to 1 minute is, again, there's things like if an electric bus is equipped with air brakes, once you've engaged high voltage, that's when your air compressor is going to be powered on. And at that point, that air compressor has to fill those air tanks up to a point to where you're safe to take that bus out on route. So, you know, just like a diesel bus, when you get in there and crank it up, if it's got air brakes, you got to sit there and wait for those air tanks to fill up. The same is true of an electric school bus. Once those startup function checks are completed, ensure that there are no faults on the driver's display. Next slide. At this point, perform the pre-trip inspection at this time. You know, whatever that is, follow your fleet's pre-trip inspection guidelines. But once the pre-trip inspection is complete, you can return to the driver's seat and depress the foot brake. Go ahead and you know, pull the yellow parking brake switch to release it or push it, depending on what system you have, and then press the forward or reverse drive selector as necessary. Next slide. Now, this seems like I'm getting a little too detailed on the steps here, but there's a reason, and I'll explain that here at this step. So remove your foot from the foot brake and press the accelerator pedal to start driving. Having driven both diesel and electric school buses, I'd say one of the main differences that I take away from it, outside of it being way quieter, is the fact that in a diesel school bus, as soon as you let your foot off the brake, that bus is wanting to rear forward on you. Whereas in an electric school bus, if you take your foot off the brake, it just sits there. It's not going to move until you actually physically push that accelerate pedal to make it start driving. So that's a difference, and it's to me, it's a much better experience from that perspective. So once the trip's complete, stop the bus in a safe location. Place the bus in neutral by pressing the N button on the push button shifter, and then set the parking brake. Depending on the bus, you can also just set the parking brake and it will automatically put the bus into neutral. But again, just to be safe, these are some steps to be aware of. And then lastly, turn the ignition switch to the off position to shut down the bus. Next slide. That covers my portion. Maurice, I will turn it back over to you, sir.
Yeah, we'll be sure to unmute this time. You can't have a webinar unless somebody is muted while talking. Thank you so much, Mark. I appreciate it. Thank you to everyone. And we'll open this up to some questions if you have any. There was one question that came through that I wanted to ask the panel. I'm sorry, I lost this. There was a discussion about tread wear, increased tread wear. How would you describe how much more tread wear is expected with electric buses? Also, will you describe specific tires or treads are required? And I'll open it up to everyone. And Brandon, you're muted.
I just unmuted. Can you hear me?
Yeah, I can hear you. Go ahead.
Cool. All right. So yeah, with the tire tread wear, no, I wouldn't describe any additional tread wear being a component of these buses, because what we're installing is basically going to be standard to the industry. We don't have necessarily any different compounds like you might hear about on like your Teslas and your other vehicles like that. The reason being that those are a little bit different on your standard everyday EV you might see on the road is because they want them to be as quiet as absolutely possible. And of course, ride a little bit better too, right? So we're not as concerned about that when we're talking about commercial vehicles. So while there are compounds out there by some manufacturers, I can think of specifically Goodyear and Michelin have their own. It's definitely not required, and the tread wear we don't expect it to be anything additional. Every manufacturer here has got tires that meet the weight specifications, so you should not expect anything additional, as well as we've got torque management, so it's not like we're going to be doing burnouts anytime that we really get after that accelerator. So thank you for your question, but to answer it, no, nothing big expected and nothing special required for your fleet.
Maurice, I would add just feedback specifically from customers that I've talked to. And again, feedback varies, right? But ultimately, some of them have indicated that because of the change of the center of gravity on that bus, that they're actually seeing a better they're getting more life out of their tires than they were with their diesel counterparts or, internal combustion engine counterparts. And again, that's because that center of gravity changes on an electric bus versus you're front loaded, whereas on an electric bus, you're more center loaded. So you have more even wear.
And
Fantastic.
one other small thing, Maurice, I'd mention is that because you're compared to a diesel bus, so if the attendee asking this question runs diesel buses, which I assume they do, there will be some limitations on which tires are used just because of additional weight. So it has to have the proper weight rating for an EV bus, which can be, up to 1,000 pounds more than a typical diesel school bus. So that might be the only difference that experience from what they're running today.
All right, so I've got another question here from Theo James. Do you need an electrician certification to perform maintenance on electric buses? Anyone?
I can jump in and be the first one to take a swing at it. But so we've got essentially a training program for technicians. We train our dealer network on high voltage systems, and we certify them to be able to work on these electric school buses. So currently, our dealerships are able to service the high voltage systems. And then there is a plan in the future to extend that out to fleets as well. But right now, our dealerships are able to service high voltage systems.
Yeah, that'd be the same for us. We aren't at this point training customers to work on high voltage. The training really includes just safety related to high voltage, as they'll be doing other work in and around the bus. But actually doing any high voltage level service wouldn't be available until sometime in the future.
All right. And Alejandro Ramos has a question. It says, how many miles typically can an electric school bus travel fully charged?
That varies, but I think the standard answer is going to be somewhere between, I think, 60 miles and anywhere up to 155. So this depends on, of course, the platform that you go with and the amount of batteries and the entire propulsion system. But this is not something that's going to be limiting, because you've got a fairly good range of miles and things like that to choose from. Options with batteries, as I said.
And I'll also dovetail your point back to battery management with the operator and using your regen to get the maximum range out of the battery. Let's see, is a hilly terrain, what is the range of the, okay, sorry, that was just pretty much answered. Let's see, what else do we have here? Okay, I think that's kind of about it. We've had some of the questions answered already in the chat. See if we got anything that hasn't been answered. I think it was mentioned that electric school buses can do vehicle to grid. Is this just line EBS or just electric school buses in general? And which chargers are capable for V2G?
I'd say you'd have to check with your school bus OEM to see which chargers would be compatible for V2G. Our buses are compatible. You have to use a specific charger, so I think it's different for every OEM. Of course, the most important thing with V2G is working with your local utility. Not all utilities are ready for V2G and don't have a program to support it at this time. Some do. So that would be step one, to see if it's even available for you to work with your utility to have a V2G program in your market.
Okay, kind of jumping around here. Also says a question is, how much notice will the bus give you before it runs completely out of battery power?
That just kind of varies per manufacturer as well. But what I can say is that you will have some sort of notification, whether that's audible, visual, or both. You will know that you're getting a little bit low. And in a situation where, on some of these manufacturers, if you get low enough, say 5%, 3%, 2% state of charge remaining, there will be a case where you possibly get derated. I don't want to speak for everybody else, but I can tell you that our buses will derate you at 3%. And so you can just take that as an example. And what that will do is it'll take you from a 400-volt system to a 200-volt system. So trying to engage as many of the feelings as we can. Again, you're going to see it, feel it, hear it. And if you run past all the stop signs and still keep going, then you can run it up to zero. But yes, you will experience a derate.
Okay. Would you please discuss the pros and cons of preconditioning the vehicle with electric motor versus an auxiliary motor powered by a diesel? Is that too broad? It's that we hear of battery degradation, specifically in colder weather, and want to highlight that this might be mitigated given proper preconditioning. The amount of diesel used by an auxiliary heaters is significant, less than if the entire bus were powered by diesel. Can you share your perspectives?
Well, I guess the perspective on that would be that, and I can't see the question, I apologize, but maybe I'll scroll down a little bit. Okay, there it is. So, specifically when we're talking about colder weather, what you're going to see, this doesn't necessarily I would say it doesn't affect degradation, but what it's going to do is, as I said in the presentation, it's going to affect your overall range. If you hop in the vehicle, plan on driving it away right away, those batteries, if it's a very, very cold morning, or in the cases of very hot morning as well, they're going to be using a little bit extra energy in order to get that up to its proper operating temperature. So I would definitely say that we can mitigate some of the state of charge loss with proper preconditioning, and as well just allow the vehicle a little bit of a slower time to get up to operating temperature. Much like a normal internal combustion vehicle. Last thing you would want to do is kind of get into your brand new Honda and start it up and then go full throttle. The same thing we would want to do here. If we can give it a little bit more time, it's better for the overall system health.
I'd make one more comment on diesel fuel-fired heaters, just to point out that although there will be some range improvement when you're using a diesel fuel-fired heater, really the main benefit, at least in our product, is to supplement the cabin heat, right? You have electric heaters that run the cabin heat on the buses. But when you're talking about extreme cold conditions, where you're dealing with, sub-zero temperatures, which some school districts do, the electric heaters probably won't get it to a comfort level that the school district would want to operate them. So it really supplements that heat, just improve cabin temperature and make it more comfortable. Not true in all markets, and there's some markets where we simply tell customers, you don't need one, don't waste your money. But there are markets where it is a good strategy to have.
There's a question here. Go
I
ahead.
would just, one more thing, Maurice, I would add, I think what Brandon laid out in his presentation was critical, was regardless of how you're preconditioning the bus, it is an electric school bus. So when you are doing that preconditioning process in the morning, make sure that bus is hooked up to some sort of external power, like the charger, obviously. So that way, as you're going through the preconditioning process, it's using energy from the grid to perform that versus energy from your battery system.
Excellent, thank you. Another question here is, are these electric school buses built around the high voltage battery or retrofitted diesel buses? Is anybody retrofitting?
No, these are, I think, and I don't know if I want to speak for everybody, I think everyone's building it from the ground up. We do sell diesel products as well, but we build these buses to be electric powered only.
Yeah, that's accurate. We utilize our standard C2 chassis, but it is an electrified chassis built from the ground up, and those chassis come to us electrified, and we body them in High Point at Thomas. So yeah, I think everyone is, there's no one on this call is a retrofitter.
Right, good. And on the other side of this, could any or all of you share an insightful experience or story related to addressing a complaint? Has there been any downsides or the complaints with these products that you guys gotten?
Yeah, I'll point out a couple that are, I don't want to call common, but we've heard. Generally, I think some of the concerns come around charging, and it kind of starts with if a customer decides to kind of go off on their own and purchase chargers without talking to their OEM. I think that's very important, and I think we'd all agree on the call that they should consult with the OEM before selecting chargers, as not everything works as intended with every product. So generally, when there is a problem, it's because there wasn't a proper consultation. So we always encourage folks to make us part of that charging solution so that we can make sure that our product will work as intended with the charger they select. I'd say that's a big one. And the second one is just, proper training, driver habits and what have you. Many times when someone says, hey, I'm not getting the range I anticipated, it's because the drivers didn't go through proper training or following all the protocols to really extend range. So I say those are the most common ones that we have to address, but there's ways to resolve both of those.
Anyone else on that? All right, good. Another question says, can you drive away with the charge cable connected?
I'll answer that. No, you can't. So the bus is going to let you know that the charger is connected, and you would not be able to engage that bus in drive or anything like that. It's not going to, you're not going to be able to. So as soon as you get in there and you try, it's going to be like, hey, you've got a charger connected. You're not going anywhere. So, and I'm sure that's true of all electric bus manufacturers.
And is there a way to get an electric shock while connecting or disconnecting the charge plug?
No, there's really not a chance of that unless there's any sort of major damage to the charger or the cable. As you are connecting, the only voltage, the only power that's going through that head is just a very extremely low pilot voltage. So once it reads the pilot from the other side, in this case the vehicle, then it will lock in. You will not be able to remove it, and then it will start charging. So that's the only time there's going to be any high voltage going through, when it is connected, communicated, pilot has met the proper specifications, and it is locked. So a lot of safety things built into those systems.
Excellent. All right, just looking, it doesn't seem to be too many other questions that haven't been answered. Okay. Let's see, are heat pumps standard equipment in buses across the industry, or is there a range of HVAC system types used depending upon the manufacturer?
Yeah, I'll talk to that since I think it was in my part of the presentation. Yeah, as I mentioned, it's just kind of depending on the configuration that you choose and the manufacturer that you end up with. We all do things just a little bit differently. So yeah, I would say, to answer your question, yes, there's a range of HVAC system types. It's just whether you go with one or the other, they might change a little bit, but overall, what we're all focused on is making these things as efficient as possible and giving people the power to manage that and be efficient, even though we want to keep everything inside nice and comfortable, right? So yes, while there's a different range, there's certainly a focus on efficiency even when it comes to comfort.
Sure thing. And then Dennis Johnson asks, given the need to be connected to power during preconditioning, is the conclusion that the fleet has is the conclusion that the fleet needs a charger for each bus?
Not necessarily. I mean, there are chargers that will higher power ones that will charge 2 buses simultaneously. So you could use a charger like that, would have 2 different ports on it, could charge two separate buses at the same time, and therefore precondition them at the same time.
And in general, 2 is the max?
What was the question? I'm sorry.
I said in general, it's 2 buses to would be the maximum. Or are there situations where you can have 3 or 4 from one charger?
There's,
Go ahead. Sorry.
no, yeah, there are other systems out there. There is, for example, there's a system that has a 200 kilowatt power cabinet, and that can feed up to 8 dispensers simultaneously. So that's an example of a single power cabinet that's going to be able to simultaneously charge 8 buses and therefore simultaneously precondition 8 buses. That's an example of some of the variation out there, but Albert's correct, having a single charger splitting power between 2 buses is very ideal as well. Albert, were you going to add to that? I'm sorry, I cut you off there.
No, that was a great answer. Thank you.
I also want to make it clear that this preconditioning feature, you're not required to use that. You're not going to run into any specific issues if you don't use that every single time. The biggest benefit again is we're going to see on the really, really cold days and the really warm days. If you live in an extreme climate, I would definitely recommend that you have your battery able to precondition every single time. If not, take some steps, store it indoors. Take a little bit of time to start the vehicle before your route so you can kind of warm it up. But no, there's no requirement to precondition every single time, every single route, every single day.
Yeah, Brandon, that's a really good point, because we're really talking about extreme cold essentially. If you live in a mild climate, you can hop in these things and go. There's not a whole lot of preconditioning that needs to be done. So.
All right. Well, I think we're about to end. How often does battery coolant need to be changed in an electric school bus?
That probably varies. For us, it's 5 years, 150,000 miles.
Yeah, standard coolant intervals for the most part. What you're going to see getting out of your normal vehicle is going to be the same thing here. The systems are at their core, they're going to be using the same sort of metals and the same sort of alloys, and that fluid is going to over time degrade just like any other fluid would. So yeah, your standard service intervals are probably going to apply here as well. Fantastic.
All right, well, it looks like the questions that are coming through for the most part now have all been answered. I would ask if anyone has anything that they want to, kind of conclude with or put out there that you feel like you may have missed or something you want to say. Brandon?
Guys, thank you so much for all the good questions, and it seems like it's obvious that we have a lot of people paying close attention. So we all appreciate that. Thank you for your interest in learning more about our little industry here, and very proud to be a part of this. So take any more questions if we want to, but that's all for me.
Albert?
No, I just wanted to reiterate and say, yeah, great questions. It's you can tell from the questions, having done these type of webinars years ago, you can tell folks are already way more educated about EV school buses than when these things first got into the market. So I think we should see and continue to see further adoption, and it's exciting for our industry. So just happy to be a part of it.
And before I ask you, Mark, let me throw one more out here. It says, are there any major differences in an electric school bus and a public transit bus?
Certainly allow batteries to put. Transit, you'll see batteries on the roof, for example. It's just with some of the federal motor vehicle safety standards in the school bus world, we have some limitations on what we can do versus what the transit world can do. So I'd say that's one of the major differences right there.
is battery replacement being on the roof as opposed to under the floor.
Yeah, I think on transit, they put them wherever they can, really.
That's true.
They definitely have more range related issues than the school bus world does.
Yeah, that's it. You know, with the school bus world, that you have a lot of places have middays that they can charge. You know, you don't have the battery issue or the range issues that you might have in the transit world. You're absolutely right. All right, and Mark, do you have anything you'd like to add before we wrap up?
I think Brandon might have put one more question down in the chat. Maurice, if you want to catch that one. I might have been wrong, but I saw it pop up.
It seems like the buses can be designed in more aerodynamic way. Was this considered?
Yeah, I mean, first and foremost, regardless of what's powering the bus, it's really all about safety. You know, school buses don't evolve that much in terms of structure of the body and the chassis because they're extremely safe. And we'll always err on the side of safety versus fuel economy or range because of that. So that's kind of my take on it.
Yeah, we're the most, heavily federally regulated vehicle on the road, and therefore we're the safest form of transportation on the road. So that does not lead to sweeping design changes typically. You know, if it works, keep it going. And we've all got great safety track records, so we want to keep that intact.
All right, and lastly here, it says, it's a question about longer battery life. Are there recommendations about not fully charging or discharging batteries? Will you describe these and the impacts to the vehicle range for route planning, and how are these considered? And what are the max miles, and how are the max miles impacted? So I can tell you, with like the cars, they tell you want to go to 80% as opposed to 100. Is that the same with the school buses? Or am I not catching his question?
Well, typically you can't charge it to the battery's full capability anyway, because it's protected for that overcharging or undercharging scenario.
Okay.
So I think when a school district sees 100% state of charge on the battery, it's really only charged up, you know, depending on the manufacturer, probably 80 to 90% of its full capacity anyway.
Okay.
So it's kind of built
Okay.
in to protect it.
Yeah, these batteries are all commercial grade batteries, and so charging them to 100% is not going to hurt them. I do tell school districts and drivers, like, hey, operationally, if you don't need to charge to 100%, then don't. If you can cover your routes, just because as you get from, like, say 90% state of charge all the way up to 100, that charging speed will start to slow, and from like 98 to 100% would be almost like a trickle charge. So again, if you really want to take advantage of the fastest charge times possible, then, you know, if you don't need 100% to cover the route, go ahead and stop it at 90 and call it good for the next day's routes. The one thing I will state that's important to the question that was asked was, now discharging is a different story. Discharging to 0% is not good for the batteries at all. So that is where being you know, cognizant of your state of charge is super important, because again, if you look at most of the manufacturers out there and these battery manufacturers, if you look at the warranty language, they do have specific language around 0% state of charge events. So again, you want to avoid draining that battery all the way down to 0%, just because it does affect the battery life over time.
All right, so with that, I will ask Ryan to step in, and thank you guys very much. Brandon, Mark, Albert, fantastic job. Thank you much. Ryan?
Yeah, thanks everybody. Thanks guys for having some great content here. I know it was really appreciated. Thanks everybody for joining. Like I said, we have 3 more modules to go that will probably be available throughout the spring and summer. So please follow us there. You can find all the information you need on driveelectric.gov. But thanks again. Appreciate it. Have a good day, everyone.